Hey there, everyone. First of all, I'd like to thank everyone that's back so far. It's been brilliant. We're currently at £600. Hopefully, over the next few days, we'll get a little bit more, and we'll get to our final target of 5,000 before the 31st of March. Anyway, this video is going to show you how you play another one of the levels. This one is going to be the maze level. So let's get into that. So let's see our objective. Let's see what we've got to do first. So in this puzzle, we have to build a robot which is capable of navigating this maze and getting from the start line to the finish line. Well, let's have a little look at the problem. So, one way to solve this problem would be to get the robot to follow a wall. It might not be the fastest way to solve the maze, but it'll definitely get to the end. So we could follow this left wall here. So if we follow the left wall, we'd go up here, along here. It would keep coming through, and we'd come around, up, through here, along. We'd go through the zigzag, back out the zigzag, up, down here, and then we'd end up going all the way down here and even coming to the bottom. So let's see what happens if we get the robot to follow the right wall. So if we get the robot to follow the right wall, the robot would come up, along, round, take the wrong turn here, go down here, turn around, come back, and come this way, take the wrong turn again, and a third wrong turn, but it wouldn't take this mistake here and end up having to go all the way around this bottom part, so this should be much quicker to get the robot to follow the right wall. So let's do that. Let's head back to the robot construction. Right, now first we select a main body. For this one I'm going to choose the third main body. This is because it's got, as you can see on the sides, it's got some protective parts which stop your wheels from, well, colliding with the walls quite so easily, so they can't get caught on edges and stuff. I mean, you could use the other two robot bodies, but this one will make it slightly easier because you won't have to worry about your wheels getting caught. So I'll place that down. And let's add some sensors. And this one I'm going to use the ultrasonic rangers. These give you back a distance to what they can detect in front of them. So we'll place one of these. So we want to have one looking at the front, so I'm going to place that one there like that, and I can connect the front one to input 1. Then we're going to get a second one looking. Now we want this to look to the right so it can follow the right wall. So if we put this one here like that, and I'm just going to re-angle my camera so I can see better. So that looks about good there. We've got some nice coverage. Notice you can't put your sensor in front of another sensor's vision, although the visions can go through each other. This is because if you place this here, this sensor here would just read out the whole time the distance it is to the other sensor in front of it, and you don't want that. So we'll have to place this here. And we'll connect this one to input 2. Now let's add some wheels. So we're currently looking at the right the right side of the robot. So we'll put this one here, connect that to the right motor, being the right side, and this one here, and we'll connect this one to the left motor. Now we want to add some, I'm going to add some caster wheels so it doesn't rock about everywhere to the bottom. So we'll add one there, and come to the other side, and we'll add another one here. Now I'm just looking at this from the side, and you can see there's the height difference of these wheels doesn't look great, so I'm just going to reposition these wheels. Select the wheels and delete them. Select the wheel and delete it. So let's choose that wheel again. This time I'll have a better look, and wants to go about there. Looks good. So this is the right one, and do the left one, and we'll put this one at the same height as well. Just zoom in a bit so I can get a better view. I think about there looks good. Okay, like the left motor. I can always rearrange their height later if I decide that they're still a bit wonky. So, let's now go to the circuit board view and we'll give the robot its brains. So now you can see here down on the left we have our inputs and then our outputs to the motors on the right. Now input 1, we connected that one to the sensor that was facing forwards, and input 2, we connected that one to the sensor that was facing to the right. Now these sensors output a number between 1 and 0, depending on how far away they detect the object. So if it's at max range, they'll give out 1, and if something in between, they'll say give out 0.5, and if it's right up against it, it would give out 0. So we now need to do something with these numbers because we can't use numbers with logic gates because logic gates don't understand numbers, and same goes for these wheels. They don't understand numbers either. They only understand, true or false, on or off. So we're going to have to use some comparison gates to turn these numbers into bools, which are, on off. So to do this, first I'm going to get a less than comparison gate and place it next to the forward-facing sensor, so we can detect when the forward-facing sensor gets close to something. And now I'm going to add another gate here. Now this is a static value, so this is a number that we're going to compare to. So we can see whether this number that's coming from the sensor is less than this number. So I'm going to give this a value of 0.7, and now I'm going to wire it up here. So now this will be true when the range of the sensor is 0.7 or less. Right, so when that happens, we're going to want the robot to turn, let's think about this, left. Yes, we want the robot to turn left when this happens, because the rest of the time we want it to turn right. So now to get it to turn left, we could do this by turning the right motor on, or we could do it by changing direction of the left motor and leaving the motors on all the time. So what I'm going to do is I'm going to leave the motors on all the time. So now to do this I'm going to use a NOT logic. Now the NOT logic gate just gives out true when it receives an input of false. So if I don't wire it up, it's just going to give out a value of on all the time. So we'll use that there and that there. So now the wheels will be spinning if we go back. Yep, there they go, spinning away. Head back again. So then let's link this one up, and we want the robot to turn left. So to do that, we change direction of the left motor. Yes. So let's see if it works. So the robot's going to run forwards, and then when it gets close to this wall, it should turn left. Ah, there we go. But now it's crashing into the wall, and it's not quite turned far enough, so we need to fix this. Well, this is where this right sensor comes in. We now want this right sensor to keep us a certain distance from the right hand wall so we can follow it. So we want to say if it's getting too close, we want it to turn away from the wall, and if it's too far away from the wall, we want it to turn towards the wall. So to do this, we're going to need to split the input that's coming from the right sensor. So split it into two so we can use it twice. And we're going to use now a greater than and a less than gate, and I'm going to have to add a new static value here. So let's say if it's less than, if it's greater than 0.9, so we'll wire this one up. So if it's greater than 0.9, wire this one up. Now if it's greater than 0.9, that means it's too far away from the wall, so we want it to turn towards the wall. Now to turn towards the wall, we'd want the robot to turn right, so we'll send this one to the right motor. And now let's say if it's closer than 0.7, so in other words if the number is less than 0.7 that the range is giving out, we're going to want the robot to turn away from the wall because it's too close and it's going to be running into the wall. So we want to send this one to the left motor. but the left motor's already got one wired up, so we're going to have to use another logic gate. This is the OR logic gate, so this will give true if either of the inputs it receives are true. So let's place that there, wire this one up to there, do the same with this one, then hook that up to the left motor. Now the robot should be good to go. Let's give it a play, let's see what happens. And away the robot goes. Now it should turn left, and there we go. And you'll see, and it's now turning right back towards the wall, so it's keeping the wall at the same distance. Should turn left again here, and now right as it detects that there's nothing on its right hand side, so it's hugging this right hand wall. Let's put it into fast forward, and let's see if it completes the puzzle. Away it goes. Now it should do a U-turn hopefully. Ah, brilliant. And down this wall. It turns around again. And one final U-turn. And round the last corner and across the finish line. Yeah, so that isn't the only way to complete this level. I mean, we could have had it following the left wall, and we could have had it so it takes the right turns every time, but that's one of the possible solutions. I hope you've enjoyed this video, this has got you interested. If you haven't seen anything already about the game, you can check more out on the webpage, which will be in the description below, and you can also head over to Kickstarter and have a check out of it there. We still need quite a bit of funding, so if you want to play this game, it'd be really appreciated if you back the game, and then hopefully I'll get enough funding so I can complete it. Anyway, thanks guys for watching. Bye.